Yeah, you're welcome back with your own boy, Edu Ada. Good. We'll be considering simultaneous equations, and this will be one of the series on simultaneous equations. Just have two linear simultaneous equations, such that the variable, the power of the variable, is one. So subsequent videos will be having one linear, one quadratic, can have one linear, any other polynomial equation. Yes, we have them. So let's start with this. The first one. Quickly, when we talk about simultaneous equations, it deals with looking for two or more variables simultaneously. I mean, at the same time, you are solving for the two of them. So you have the name implies is a pair of linear equations. So I don't have to bore you more about that. Let's just solve and let's go. Have this, sharing this into two. Solution 1, you can have 4x minus 3 is equal to 12. It goes to minus 12. Minus 12. Apology. Let me check my 4x minus 3 is equal to 3x plus 2 plus y. So this is not supposed to be there. Checking my question again. And 3x, okay. So we shouldn't have this. I have this. 4x minus 3 is equal to 3x. 3x plus y. So here you can collect like terms such that you have x and y on one side and you have the value, the constant, which is this, on one side. So you can say we have 4x minus 3x minus y is equal to 3. Then this becomes x minus y equal to 3. You see that? So yeah, we're going to be solving this simultaneous equation with different methods. So here, x minus y equal to 3. Then you go, this forms equal. I want this one to form equation 1. The second part of it, that says 3x plus y. So you have 3x, sorry, 3x plus y. Collect the like terms. Directly, you have minus 5x minus 5x, then minus 2y. Everything is equals to minus 12. So what do you have? 3x minus 5x, that is minus 2x. Then y minus 2y, that's minus y. Everything is equals to minus 12. You can factor out the subtraction sign, the negative sign there, minus y, that is equals to minus 12. So if you divide through by minus 1, you're going to be having, or you multiply both sides by minus 1, any of them, you get 2x plus this. Sorry, this should be plus, and that becomes 12. This gives us equation 2. Yes. So we solve equation 1 and equation 2. We can solve them. We solve them simultaneously. We can use, let's solve them simultaneously. We have x minus y is equals to 3. Then you have 2x plus y is equals to 12. What do you do? Let's use a method called elimination method first. Then in another video, we'll be using substitution method. I'll take substitution method some other time. So you have this. All you have to do, look at this. The coefficient of the 2y in the two equations, they are 1. This plus 1, this minus 1. So which means if we add them together, you will get 0. So it makes work easier for us. You have plus here. This plus 2x plus 2x, you have 3x. Minus y plus y, that is just plus 0. You have 0 there. Equal to 3 plus 12, that is 15. So 3x is equal to 15. Dividing both sides by 3. This cancel out this. So our x is equal to 5. You see that? So with this question, we can actually solve it by equation method. Here, if we make x solve the formula in equation 1, we make x solve the formula in equation 2, then whatever we have at the right hand side, equate them to each other, we still get x to be 5. Yes. Then, and first get y from there, then we get x to be 5 too. You know that since we have x, we can use it. Okay, let's eliminate x. When we got x, before we got x, we have to eliminate y, right? So we eliminate x now. Follow me up. I'm cleaning this. To eliminate x, what do? Yeah, the coefficient of both of them should be equal. The coefficient of x in equation 1 is 1. The coefficient of x in equation 2 is 2. So making them equal, you have to just this times 2, this times 1. So what do you have? You're going to be having 2x minus 2y is equal to 6. Then you have 2x plus y is equal to 12. These, we are now equal coefficients, but they have the same sign, plus plus. How can you make this to be 0? If you put addition sign, you are complicating the matter. So by the time you bring in subtraction sign, by the time you subtract each other from 2x from 2x, you have 0. This gives you 0. This will give you minus 2y minus 2y. There's a minus here, minus open bracket y. That's minus 2y minus y. That's minus 3y, isn't it? So you have minus 3y is equal to 6 minus 12. That will be minus 6. So what do you have? Divide both sides by minus 3. This cuts this. Minus cancel out. Minus divided by minus is plus. 3 here 1. 3 here is 1. 3 here is 2. Do you get that? So 3 here gives us 2. Oh, sorry. I'm having so you have this here. Sorry about that. So which means our y can be equal to 2. If you substitute any of these values, we got x to be 5, we got y to be 2. You can check from here. Let's check from this equation. X was 5, right? 5 minus our y is 2, that is 3. Put your x here, 2 times 5, that is 10, plus 2, plus 2, which is y, that is 12. So that confirms our results. Thank you for joining me on this. Okay, we have a question 2 to deal with. Solve question 2. You have 1 upon x have 1 upon x, and you have the other one. Look at this. 1 solution 2 now. 1 upon x minus 1 upon y is equals to 5. Then you have 1 upon x plus 1 upon y is equal to 7. Something is consistent here. 1 upon x, 1 upon x, 1 upon y, 1 upon y. I can let each of them to be something. Then it makes my work very easy for me. And I can just say let 1 upon x be equal to p, and 1 upon y be equal to q. So I'm going to be having p minus q is equal to 5, equation 1. Then p plus q is equal to 7. Do you see that? So here you go. What do? Like I said initially, using what? Elimination method, you can just subtract this to eliminate p. If you eliminate p there, what do you have? This is 0 minus q, that's minus 2q. 5 minus 7, that's minus 2. Dividing both sides by minus 2 because that's the coefficient of q. Then q becomes what? 1. This cancel out this, 2 into 1. So that's how I came about my 1. Now that your q is 1, let's go and eliminate. We eliminated p, right? Let's eliminate q now so that we get p. Our q is 1, don't forget. So now, putting addition sign here, this becomes 2p minus q plus q, that is 0. 5 plus this, that is 12. Then 2p can be equal to 12. Dividing both sides by 2. 2 cancel out 2. 2 here is 6. So p is equal to 6. Now you see that? Sorted. Very good. So now, don't forget that's not what we are looking for. I say let 1 over x be equal to p in my question. Then let 1 over y be equal to q. And our q is 1. Since our q is 1, our p is 6, right? So 1 over 6, 1 over x rather, is equal to what? P. That implies that 1 over x is equal to 1. 1 is 1 over 1. But then you cross multiply. We multiply both sides by x. So x, of course, will be equal to 1. The second one, we said 1 over y is equal to q, right? So if 1 over y is equal to q, that means 1 over y is equal to 6. Multiplying both sides by y, y times this times this. What do we have eventually? We're going to be having this cancel out this. 1 will be equal to 6y. Dividing both sides by 6. So 1 over 6 will be equals to y, which means y is equal to 1 over 6. You get that? So our x is 1 and our y is 1 over 6. Check this in this equation so we get the right answer. Thank you very much for staying with me. Solve similar questions and you'll be fine. Bye for now.